In the last video, I covered the process of deploying a contract to the Ethereum network. I want to mention something that seems interesting. If you recall, when I spoke about sending money from one person to another, we had to create a transaction. And when we sent money from one person to another, that modified the data that was stored on the blockchain. On the blockchain, there's probably some record of account that says you have 100 Ether, and then another person's account which says you have 0 Ether. So when the transaction is submitted, it updates one person's balance to 99 Ether and the other sender to 1 Ether. In the previous video, when I spoke about creating a contract, I said that to create that contract and deploy it to the network, we had to submit a transaction. And so in theory, that is probably updating some of the data to the blockchain as well. And that deployed contract is now on the blockchain, and we need some record in there that says, hey, here is what the current value of message is. So I want to show you a new diagram. So I'll just go ahead and pull it up. And I'm just going to resize it. All right. And I want to explain that the theme seems to be that anytime we want to update any data on the blockchain, we have to submit a transaction, and that is a rule that holds true for any activity that we do with Ethereum. Anytime we want to change any data that we have stored in the blockchain, we're going to have to submit a transaction. And what's more, not only do we have to submit a transaction, but we have to wait for it to be mined or go through the proof of work algorithm that can take anywhere from 10 to 30 seconds to execute. So anytime we're changing any data, we have to submit a transaction and wait for the transaction to be approved before we can say confidently, hey, the data stored in the blockchain has been updated. So why is this important? Well, remember, I'm going to show you. So remember these two functions. We have our and which are the same here with represented with the buttons. So we have our get message, and then we have our set message, right? And so message here retrieves a value, and set message updates a value. So message is a piece of data that is being stored on the blockchain. It's stored in the contract. So if I'm saying that updating any value on the blockchain involves a transaction, what does that mean about set message? Or what does that say about set message? So if I run set message, does that involve a transaction? So now I want to head to another diagram so we can think about it. And let me see if I have the right diagram pulled up. I do not, but I will pull it up right now. Let's see. There it is. That's the one I want to pull up. And I will share it with you all. Where is it? There it is. All right. So this is resize that so you can see clearly. All right. All right, so let's think about this. So set message here involves modifying the data, so it has to change the network, right? It has to change the blockchain. What's even more interesting is that get message up here doesn't change anything at all, but they both are functions. So what is the difference between these two functions? One involves a transaction and the other does not. So this was a long-winded way to introduce the different ways to run functions on a contract. So I'm going to pull up another diagram because there are two ways that we can invoke functions to run on our contracts. These two ways will result in very different behavior. And we're literally talking about the different ways we can execute a function, set message, or the function to retrieve the message value. So the first way to call a function is literally calling a function. So let me go ahead and pull up that diagram. And close this one out. Close this one out. All right. So I'll go ahead and resize that. All right. So again, when you want to call a function, you're going to literally call a function. So that's one way, right? So when you're calling a function, it cannot modify the contract's data at all. A good example of this would be our message function. That doesn't modify our contract's data. In fact, I'll go over to Remix. Here's our message function, and if I hover it, what you'll see is a little pop-up, a little bubble window that says message dash call. Okay, so that means that we're literally calling the function. Now, if I click it, and if I click it, that results in a call and we literally get back a return value that appears to be right. Now, calling a function can return data, as we just saw. When we call a function, it runs instantly because it does not involve a transaction. It does not need to be mined. Finally, calling a function is free to do. So calling a function in our contract behaves the same as in any other programming language. Where things start to get interesting is when we want to modify a contract's data. When we want to modify any data stored in our contract, we're not going to call a function anymore. Now, you may hear me saying call or invoke a function simply because that's just the language that I'm used to using. But in reality, anytime I'm going to invoke a function that is essentially going to modify data, we're going to be invoking it by sending a transaction that targets our contract's instance and targets a specific function. If you hover over the set message function, eventually we'll get a little bubble window there that says set message dash transact in parentheses not payable. And so transact means that we're going to create a transaction that targets this function. Now, there are some very important gotchas that I have to cover. Number one, anytime we submit a transaction to the network, it takes time to be processed. For example, when I sent money to myself using the the R.I.S.E Ether faucet here, it took time to be executed. And we know that it took about 15 seconds for the proof of work algorithm to be confirmed, and another 10 seconds for it to be confirmed by other nodes, and another 5 seconds for it to be returned to our site here. So anytime we're trying to update a value, anytime on any contract, it's going to take somewhere from 15 to 30 seconds for it to execute and give us a notification back that says, hey, everything looks good. Number two, whenever we send a transaction to a function that returns a transaction hash, which is what this is here. This is a transaction hash. So if we look down here in the R.I.S.E faucet, we see that transaction hash returned, and we know it's complete. So whenever we send a transaction to a function, we get something back that identifies a transaction that just occurred or that you just submitted. We do not get a return value back. Even if the function that we write has something inside it that says that we're trying to return a value, we're not going to get a value back, just the hash. For example, if I change set message and I say I want to return a message and then I change the function signature to return string, Remix won't complain about that. This is the behavior of Solidity. It'll behave in a way you don't expect. So even though it appears we've invoked the set message function and get a value back, this is not the case, because since we want to update data in the contract, we have to send a transaction, and that is not instantaneous. We don't get a value back. Instead, we get a hash. Number three, last one, sending a transaction to a function costs money. And I'll talk more about this later. Sending a transaction to a function does cost money, and I'll prove it. So I'll go back here to Remix, and I'm going to invoke set message, and I'm going to attempt to update a value stored in the blockchain. But before, I'm going to go up here. Now you can see here, the amount of Ether that we have left on this account. So originally it had 100 Ether just like this one, but now it has less. So I'm going to select an account with 100 Ether just to make the point. And then I'm going to type in a string in set message called, I'll call it greetings. All right. And so then I'll run it. So I'll click set message. And now you see how much Ether I used. It had 100 in that account. Now it has 99.999996666 and so on. So it gets processed. And if you look up, you'll see that the Ether has gone down. So it costs very little Ether, but it does cost something. So when I do this, and if you look in here in the console, it looks instantaneous, doesn't it? But the difference is that it takes time when we're on public networks. So on the main Ethereum network, whether it's Ropsten, Kovan, or Rinkeby, on all these public test networks, there's a block time of 15 seconds. However, on any test network such as Remix, the block time is near instantaneous. So that is a huge gotcha. So anytime you go and look at a tutorial around Solidity, it's always written using networks that instantly process these transactions. In the real world, anytime we try to update some data, we have to wait for the 15 to 30 seconds for that data to be processed. Now, as developers, we're not used to that, right? Because we develop, our development environments always mimic the real world environments. But Remix is not mimicking the the Ethereum public network. So it doesn't work the same way. So when you're working with it in the actual public network, there is a latency of 15 to 30 seconds. So just be aware that your development environment is very different from your real public Ethereum network environment. This is why I'm using the Rinkeby network, because I want to see that delay. I want to get used to the experience of how it will be like in the real world when you're using the Ethereum public network. Because I want to build my application in such a way that it takes this latency into account and the end user is not concerned that something may be broken. All right, so I will continue this in a subsequent video.